In this video, I would like to show you Lambda expressions in Java. I have created an empty project with the main method here. So let's talk about an idea of computation. How would you express an idea of computation in Java? Imagine that we want to compute square values of numbers. So we may likely to try to create a method such as this. Method name square, taking a double parameter and returning the square by multiplying the value with itself. Of course, we can also try to add all the usual attributions here. For example, the method does not use any object attributes, so it should be made static, and it should be also made public to make it accessible in our application. And we may come up with all sorts of other Java-specific decorations and arrangements around this method. But compare this with an idea of a mathematical definition of a function. I'll just put a comment on top here. So here, function y is defined as its argument multiplied by itself. So this is Java version, and this is abstract math version of the same computation. So what's the difference between Java and abstract math? Obviously, universality and abstractness in math and programming language specific decorations in Java. Since version 8, Java allows something similar to this, like we have it here in algebra. We may formally define a function by an expression like this, but in Java, such expression, like any other expression, does not have a name. It's called a lambda function or lambda expression, and this lambda function in Java can be defined as an expression or as a block of Java statements with the return statement providing the result. To begin our coverage, let's just say that lambda expression in Java is a short block of code. Like Java method, Lambda expression can have input parameters and a return value. To make Lambda function usable in Java, step number 1, we must have an interface. Its definition would be like this. And I will comment out this square method because we're not going to use it. It was just the demonstration to compare math and Java method. Step number 2, we can create a variable of this interface type and initialize it by Lambda expression. Okay, like this. I will name it a square because this is the meaning of the value multiplying by itself. And altogether, this syntax is defining a Lambda function using input x and the expression x multiplied by itself. This part of our statement is called Lambda expression, and the semicolon belongs to the statement that evaluates this expression and assigns the result to the variable named square. This expression creates an object which is captured by our variable square. It is almost like using the new operator with classes. With new operators and with classes, we use this new in front of the class name and object constructor syntax. But here new is not necessary. Java understands that this is a Lambda expression because we use this arrow operator to create Lambda expression. Finally, step number 3, we can begin computing square values like this. Right, just examples of our Java statements. So we take our variable square, we call compute, which is defined inside of our functional interface, and of course we provide the parameters that we want to compute. So now I can save this program and test it. So these are the squares of 3 and 0.5. What is still unlike math definition of a square function is our dependency on the double data type. We still depend on this double input and return value. It would be really nice to make our compute function more generic. So we can change this to generic interface instead of hard-coded double like this. I'll duplicate my interface definition just to keep track of our changes in the sample. And so here I would like to make it generic. So I'm going to say the interface depends on some sort of type name, okay, that I'd like to use. And this type name should be replacing the double. Right, so instead of hard-coded double, now this should be pretty generic. So once compute becomes a generic method with any kind of type name of the parameter and the return type, we have to be a little bit more specific when we define the square variable. Right, so we need to say that it's a double, but at the same time, primitive data types are not allowed as generic parameters. So this is why we use the helper class, double. So let's verify that everything is working as expected. I'm saving it and testing it again. You can see that the results are the same, but this time the interface with which we capture our lambda function defined by this expression right here now can be used with any data types that support multiplication. So let's do a little bit of testing with integers. So here we can define an array of values 10, 20, and 30, and then we can create a loop with integer value in this array values, right? And inside this loop we can print square values of our integers, something very similar to this, right? So here we can say print value, rather compute square and then print the value. Another inconsistency here is that the square was defined for computing the square for doubles. We apparently need to redo this. I mean, define another expression where we use integers. I'll name it I square and use I square to make this computation. So let's see what it prints for 10, 20, and 30. Okay, so we get our results 100, 400, and 900. So this proves that lambda expressions work well with both integers and doubles, and what we have here is an example of what's officially called functional interface. Java supports annotation named functional interface to make sure that compiler will be able to verify that our interface uses only one abstract method inside this interface to be used with lambda expressions.